Hey Rock Buds, today we're going to be talking about the black minerals and black rocks they form that I know of. And by the way, how are you? Hope you guys, every single one of you, are doing fantastic. Think about you all the time, and I'm so happy to be part of your interest. I mean, a fellow rock bud. Anyway, hope this video is good. If so, please subscribe. Thank you to every one of my wonderful subscribers. I appreciate it so much. So here we go. Black minerals and black rocks. Let's look at the mineral tourmaline. Tourmaline is a felsic mineral. That means it's associated with felsic rocks. Felsic rocks are rocks that are high in quartz. Here are some hunks of pure tourmaline, but I never find it like this in nature. Instead, this is how I find it, as a part of a piece of quartz vein rock. This is very interesting, and it tells us something. What does it tell us? It tells us that just like gold, silver, and other elements, the tourmaline is flushed into sediments via hydrothermal activity. Boron is the main and unique element in black tourmaline. Volcanic activity associated with subduction and or continental crashing injects the boron-rich tourmaline into sediments. Later on, silicon-rich groundwater, sometimes hot water, picks up the tourmaline and the quartz, deposits it into quartz veins, in the same way that gold, silver, and other elements are picked up and deposited in quartz veins. The host rock weathers away, but the tourmaline-rich quartz vein is much more resistant to weathering, and so it falls out and breaks up into pieces and usually winds up rolling down into the streams. And tourmaline can also form in pegmatites, which are granite bodies with large crystals, including tourmaline. In this pegmatite, you can see black tourmaline, gray or clearish quartz, and white feldspar, which is probably sodium-rich feldspar. The green specks are emerald. Now let's look at biotite mica, a common mineral. As you guys likely know, biotite is a mineral that comes in these thin flakes, just like muscovite. And the flakes are all pressed together to form a hunk of biotite. Hunk, that is a technical term. Here is the general formula for biotite, but the main thing to note is that it's very similar to muscovite, except biotite has a little bit of iron and magnesium in it, whereas muscovite has none. Hey guys, biotite is an intermediate mineral in its reaction. That means that it is found primarily in intermediate rocks. What's an intermediate rock? An intermediate rock is a rock that has some quartz in it, but not as much quartz as a felsic rock like granite, and some iron and magnesium in it, but not as much iron and magnesium as a mafic rock like basalt. Let's look at some intermediate reaction rocks that contain biotite. This is diorite, an intermediate reaction igneous intrusive rock. And this is andesite. It is the above ground equivalent of diorite. Andesite is an intermediate igneous extrusive rock. Here are some samples of biotite gneiss. It's the metamorphic version, most likely, of diorite and andesite. Biotite gneiss is an intermediate intrusive metamorphic rock, and the black spots are biotite. Since biotite is much softer than other black minerals like tourmaline, hornblende, and pyroxene, you can check for it by trying to scratch the rock, the black stuff in the rock, with a nickel coin. If you get a bunch of gray dust, then you can be pretty sure you're looking at biotite. Let's say you've got some iron-rich sand and mud like the black beaches of Hawaii, and that stuff gets metamorphosed. The metamorphic version of this stuff would be called biotite schist. And biotite schist is made of a mixture usually of quartz and biotite. This particular one has some beautiful garnets in it that tell you this rock experienced medium to high-grade metamorphism. Now let's look at the black mineral hornblende. Hornblende is an intermediate to mafic mineral that's part of a larger group of minerals called amphiboles. It is kind of rod-shaped in appearance like this, but I never find rod shapes in the rocks that I see that contain hornblende. Here's a sample of hornblende gneiss. Now let's have a look at it. How do I know this is not biotite gneiss or a mixture of biotite and hornblende? Well, one way to tell is that hornblende is much harder than biotite and a nickel coin will not scratch it. Another way is to look for the stringy white feldspar crystals that tell you they're more calcium rich than sodium rich. Let's just do the nickel test on this rock to see if it has biotite in it or not. Of course, the nickel test is just quick and dirty, and really the way to find out what minerals are in a rock are with a chemical analysis. So we're scratching the surface here, this fresh cut surface with a nickel, and not seeming to make much headway as far as making a permanent scratch. Now we're going to scratch the top. And we probably are scratching through a little bit of the rind, the erosion rind, but when we wipe that off, I don't see a scratch there. So I'm going to conclude this is the black mineral is hornblende. So here we go again just to make sure. Hey guys, the hornblende gneiss can be the metamorphic version of rocks that are kind of in between intermediate and mafic, like a rock that's kind of in between diorite and gabbro, or one that's in between andesite and basalt, something like that. Now let's have a look at the black mineral pyroxene. Here is the chemical formula for pyroxene, but the main thing to notice is that it's rich in calcium, magnesium, and iron that makes it a mafic mineral. Pyroxene and hornblende have about the same hardness. That would be 5 to 6 on the Mohs hardness scale. So do you think a nickel coin will scratch it? Hey guys, a nickel coin has a Mohs hardness of about 3.5. That means it will not scratch hornblende or pyroxene. Here are some samples of the mineral pyroxene. Pyroxene is mostly black, but sometimes it can look a little greenish, and I think that would help to distinguish it from hornblende. But the best way to identify pyroxene is in the rocks that contain it. Here is gabbro, a mafic intrusive igneous rock, and the black spots are pyroxene. Here's another sample. And here's basalt. Same minerals as gabbro, just the extrusive version, and the black stuff is very likely pyroxene. Here's a very fine version of basalt. And here's some basalt hot off the press. Hey guys, here's a chart that shows the various hardness on the Mohs scale of different minerals. for your reference. Our last black mineral is coal. Actually, coal is not strictly a mineral because it is made mostly of carbon, an organic element. But it is black, so we go and check it out. Coal starts out as vegetation in coastal plain swamps. The vegetation gets covered over by mud or sand and gets compressed over time into coal. There are two kinds of coal. This is bituminous coal. Bituminous coal is formed by the pressure of the weight of sediments that are on top of it. I call it sedimentary coal. If bituminous coal is folded and faulted under high temperature and pressure, it becomes anthracite coal, which I call metamorphic coal. Coal has a hardness of 2 to 3, so I interpret this as meaning that bituminous coal might have a hardness of 2, anthracite maybe a hardness of 3, but I'm pretty sure a nickel coin will scratch either one of those. The best way to identify coal is by its location. Our coal in the eastern United States is located in the Valley and Ridge province, which is kind of a tanny brown on this map, and the Cumberland Plateau outlined in the blue color on this map. Of course, the western United States has coal deposits too, and here's a map showing all the coal deposits in the United States. And here's a coal map of Europe. And just for good measure, the rest of the world. Okay, most excellent rock buds, that's it for black minerals and the black rocks they compose. Thank you so much for watching, and if this video is good for you, please subscribe. I'll be coming out with videos on rocks and minerals of other colors soon. In the meantime, this is your Rock Papa coming to you from Mount Pisgah, North Carolina, saying happy rock hunting.